So for today's video, we are going to create a tutorial video for Chapter 8 for subnetting IP networks. So on this tutorial, I will going to show you a video that already made by me on how to subnet and do VLSM or variable length subnet masking. So without further ado, let's proceed to the video. Okay, so for this activity, we're going to calculate the subnet mask. Instruction is, in this activity, you are given a subnet mask in decimal format. Enter the binary representation of the subnet mask in the octet field provided. Additionally, convert the mask prefix notation, which is the prefix notation is slash x, or the value of how many ones there on the binary format in the prefix notation field. And the previous activities, we learned how to convert decimal to binary. So 255.25, the subnet mask is 255.255.254.0. So 25, we know that 255 is all from the first position to the last position will be 1, because it will be 128 plus 64 is equals to 192, then plus um, plus 32 is equals to 224, plus 16 is 240, plus 8 is 248, plus 4 is 252, plus 2 is 254, and plus 1 is 255. This one will type 1 1 1 1 1 1 1 1 1 1, and for this one we are going to type, because it's 254, we will going to minus my type 1 1 1 1, but this has a value of 255, and we know that the last digit of this represents 1, or its position is 1, so we can delete it and change it to 0 to become the value of this binary value is 254, and the last is 0 because it's 0. Then the representation for this one is um to for us to know the prefix citation, we simply count the number of ones here. So this is 16, this is 2, 16, 17, 18, 19, 20, 21, 22, 23. So it's over 23. Let's see if it's correct. It's correct. Now let's try the number. Okay. Previously the number is 254. Now it's only 240. And here we're going to type 1, and also here all the way up to the 8th position. Then 240. We know how to compute binary. Binary has positions, and every every position that has one value in bit, it will be added to the next. Okay. If there's one, if the bit value is 1 and it's on first position, it represents 128. But if it's 0, it represents 0. Okay. And subnet mask first 128. 128 plus 2 plus 64. Okay, 240 is greater than 128, so we are going to add 1. 240 minus 128 is 240. Wait, 240 minus 128 2, then 23 minus 12, 12. Let's check if it's correct. 240 minus 128. Okay, it's 112, and 112 is greater than 64, so we'll add 1. 112 minus 64 is equals to 8, is 58, and 58 is greater than 32, so 1 minus 32 is equals mm, wait, was 112 minus 64. Oh, it should be 48. My study is wrong. Oh, this will be good. Okay. 48 minus 32 is equals to 16. And 16 is greater than or equals to 16, so we will go to add 1. 16 minus 16 is equals to 0. We're going to type 0 all the way to the 8th position. This is 16. Then we're going to type 0 because the decimal value of this 8-bit, this decimal is the 8-bit binary value is 0 because the decimal value is 0. And the prefix notation is 16 is 20. Okay, it's correct. And that's how we convert subnet mask to its binary and to know its prefix notation. Thank you. So in this activity, we are doing BLSM. But this instruction is the instruction for this activity is table 1 use regular subnetting to accommodate the network shown. Table 2 uses BLSM to further subnet the network. Plug the address of the appropriate subnet to the new subnet decimal is this is the address that we are going to this is the address that we are going to subnet. It is the subnet mask of 255. It is a subnet mask of the address 192.168.5.0/24. The address. Then subnet mask is 255.255.255.0 because it has a 24 prefix length. Subnet. Then calculate 50 users per subnet. So to calculate 50 users per subnet, we are going to convert subnet mask to a binary to its 8-bit binary value. 8 and a 0. 8-bit subnet mask. the subnet mask. Then then we're going to do a subnetting to calculate 50 users per subnet. Now let's go and submit it. Um, we need uh we need 50 host address. In order to do that, we are going to raise going to type 2 and raise the number of hosts um, in our 8-bit binary. Wait, 1, 2, 3, 4, 5, 6, 7, 8. First, um, the first bit in our binary is 128, second 64, and the third is 32, fourth is 16, fifth is the value of our fifth is 8, 4, 2, and 1. We're going to raise it to um to 6. Why? It's because 2 raised to 6 is 64, and it can satisfy a 50 host address by 64. So the value of our new binary is 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. That 1, 2, 3, 4, 5, 6, 7, 8. That 1, 2, 3, 4, 5, 6, 7, 8. That 1, 1. Because the position of this is 64. And then 1, 2, and 6 zeros. 1, 2, 3, 4, 5, 6. Then our new address will be 192.168.5.192, because if we add this, the position of these two will 1 are 0. Then 26. That's our new to 5, 1, before. The next, our next address will be plus 64. 64, 1, 2, dot 168, dot 5, dot 64, plus 64, 1, 2, 8, 6, 1, 2, dot 168, dot 5, dot 1, 2. Uh, 6. All of this has its range, which is to point up to point 63, 26, and this one is to 127, and this is up to 191, 191, this is up to 255. 2 dot different by 26. Now we can now because of this range and these addresses we are able to answer our activity. So the first prefix notation will be 26, 26 for the subnet mask. Uh yeah, for the subnet mask it's 26. Then the first full subnet range is this 02.0.63. So this. Then the second is 64.2.127, and the last subnet will be this 192. Now let's check if it's correct. It's correct. Figure 2, VLSM calculation. Calculate for 20 users per subnet. Okay, now the second full subnet range under figure 1 is 192.168.5.64 here. Then the new VLSM decimal. So we need 20. We need 20 hosts. So this is for figure 2. We need we need um 20 host addresses. So in order to do that, we can use BLSM calculation. How we will able to do BLSM calculation? We are able to get the first 50 host addresses. And here it is. The original host address. The original address is 192.168.5.0.24. So that is the our first address, and we need to calculate a host address for 50 for 50 for 50 users or host addresses. We need so we do subnetting. We have our result. Our subnet result is here. We borrowed 2 bits, the last octet, and 2 bit because the value of the second bit is 64. 64 is the magic number, and um 64 is our magic number here at the first. So we need to compute 20. No. Hmm. We need to calculate 20 users per subnet. We already done 50. We're going to put this range here. We are going to calculate another 20 users per subnet. In order to do that, we are going to use VLSM or variable length subnet masking. And this will be changed to 192.168.64 um, over 20 with a perfect length of 27. Why 27? Because if our subnet if the our subnet length our prefix length is 27, our subnet mask will be 1 2 3 4 5 6 7 8 that 1 2 3 4 5 6 7 8 that 1 2 3 4 5 6 7 8 that 1 2 3 00000. That will be our subnet mask. We have three. We borrowed three bits from our host at our host portion because number is the magic number for the third bit. Or our last bit is magic number is 32. 32, and 32. Uh, uh, on 32 we are able to create a 20 20 different host addresses. Or if we can compute it, 2 raised to the number of uh, 2 raised to the number of hosts, which is 5, is equals to 32. So this we are going to add 191. It will be 1192.168.64 plus 32 is equals to 96 slash 7. The next address will be 192.168.32. Um, one 96 plus 32, 128, 30, 128, 7. Now we can see that we have the we can now um, create a 20 calculate to create 20 users per subnet. The new VLSM subnet mask will be 27 will be 2.24. Here if we convert it, the subnet mask will be 255.255.255.224. Then the VLSM prefix notation will be 27. The first full VLSM subnet range is here. Here because we use the second full subnet range in order to create this. So this. Yeah, we use this. So this will be our mm, this will be our first VLSM subnet range. Then the last will be oh yeah, and the last will be this because it's just only two. Okay, I forgot. Okay, just only two. If you want to compute the other, if you want to compute other VLSM that needs 32, that needs for example 15 or 10, we are able to create other VLSM computation here. So let's check if it's correct, and it's correct. And thank you for watching this activity. I hope you learned something. I hope I can I explained everything clear. Thank you.